Hi, today we're going to be trying to fix this Ferrex angle grinder. So this belongs to one of our local farmers and he asked could I take a look at it. And he said it's completely dead. I'll just pry the battery button there. It's showing that the battery's fully charged. If I can press it there, there we go. But when you switch it on, absolutely nothing. So I don't know whether this is going to be repairable or not. It depends what we find inside, because I know on some other tools that I've worked on, the electronics are all encased in either resin or some kind of potting compound. So we'll see what it's like when we get inside of it. So I'm just going to remove this handle so it's a bit easier to work on. Let's get the battery off. And I could just check to see that there's power coming out of the battery first. He said he's tried a different battery. I don't know how the connections work on this battery, so we've got 20 volts on those ones and 20 volts on those ones. So this appears to be a 20 or 40 volt system, so I'm not sure whether it's got two, whether you can have the batteries wired in series or parallel maybe. I think that might be the arrangement of the terminals here. Right, I'll get the battery out of the way. Let's see how this comes apart. I can see two Phillips screws there. And it looks like we've got 4 on the top here. Although getting to that one might be a bit of an issue. Let's try undoing those two first and we'll see what happens. I'll just grab a screwdriver. Actually looks like there might be 2 down here as well. So I'm not sure whether this bottom part sort of separates. We have a 3-year warranty sticker there, so I wonder if it's kind of still in warranty or not. It probably won't be after I remove this sticker though, but hey ho. I'm just going to try a spudging tool or something just in the side here. So this is a brushed motor by the look of things. I thought it might have been a brushless one. So it could be that the motor's failed or there's a problem with the micro switch here. But we do have a bit of a circuit board down here as well. Let's just zoom in and have a look. There could be a problem with the circuit board. We've got, it looks like some silicone over the top of some of the components there. And it looks like we've got a MOSFET here that sends power to the motor. So it could well be a problem with this little board here maybe. Let's see if I can get this micro switch out. I didn't fancy rebuilding a micro switch. Right. So let's see if there's any resistance. Let's see if there's any resistance on this motor here. I'll just zoom out a fraction. I'll get the meter in shot. I'll just go on to ohms and let's see what we get on here. Well, we're getting a reading on the motor there, so the motor isn't open circuit. Let's just try on here. Yeah, so we've definitely got a reading going to the motor. So I would hazard a guess it's going to be a problem on this circuit board here. I'm just going to see if I can clean this up a bit because it's a bit dirty. Right, I've cleaned the board a little bit better now, so we can actually see through this conformal coating there's a small microcontroller there. I'll just zoom down a little bit. It looks like possibly we've got another MOSFET and maybe a voltage regulator or something over here. Possibly a 0 ohm resistor or something, I'm not sure. But I can't see anything obvious blown or anything like that. I mean, I didn't actually try the switch to see if the switch was faulty, so let's just try that now. I'll just zoom back out. I'll just go into continuity. So that contact's working. Let's just try this one. So the switch is okay. So it looks like it could be a problem on this board. Wow, I've actually got, I just noticed there, it's actually got 5 volts written on there, which I presume is going to be this pin here. And I would assume that this one's probably going to be ground. So let's see if I've got 5 volts on there. I'll just go and grab the battery. I just wonder if I can get this out just to give it a bit more length there. That's better. Let's see if we've got 5 volts on there, and we don't. Oh. I've just heard a noise from the motor there. I've just heard like a crackling from the motor. I'm just wondering if the brushes have gone or something on this. Let's just see what voltage we get out of here when I press the button. I don't seem to be getting any voltage. I think the next protocol is going to be to have a look in this motor here. We'll see how that comes apart. Well, I've managed to take the motor apart and the brushes and everything look okay. So I've just plugged it back into here. I was just going to measure the voltage. But when I press the switch here, I don't know if you'll be able to hear or not. I was just getting the same crackling noise that I thought was coming from the motor. So I think it's actually coming from under the PCB here. And looking down here, it looks like we've got some possibly corrosion. So let's see if we can get this apart. I don't know if you're going to unsolder those or desolder them, or whether this little bit of plastic thing comes out maybe. And does that let you take the board out maybe? Well, after some persuasion I got the circuit board out, but I can't see anything on the underneath of it. Everything looks fine. I did try desoldering these pins as well and that didn't work. But there's 2 little notches here and they slot into sort of 2 little notches here. So I kind of just cut those off with the side cutters and then it was easier to remove with this board, which sort of slides out the way I thought it would. So I think I'm going to wash my hands and then we'll get this under the microscope and we'll see if we can see anything obvious. Right, I've got the microscope set up. Let's have a look, see if we can see anything obvious. Looks like the microcontroller there. And that's probably the voltage regulator. Now, what's that? Looks like there's a little bit of solder or something there. I can't quite make the number out on that resistor there. It could just be dirt. Looks a little bit discoloured, that resistor. It definitely looks a bit suspect. And that looks like it could be either going to the output or supply of this voltage regulator here. Right, I'll go and get the test meter and we'll see what that measures. Right, let's see what this measures, and it should be 200 ohms. That's close enough, 199.9. So I guess we'll just have to keep looking. It looks a bit not so great round here. I'm not sure whether there's any corrosion or moisture getting in here that could be affecting those wires. I can't see anything else that looks obvious. I wonder if the thermal camera would show anything, because that definitely looks a little bit discoloured, that still. I wonder if there's a short somewhere, like a shorted capacitor maybe. No, that looks very low. We've only got 12 ohms on that capacitor there. And I would have thought we should have more than that. Where does that go? And that goes to the 5. Does that go to the 5? It's a bit hard to see with this conformal coat and stuff. Looks like it goes to that pin of the IC, which does go to the 5 volts because it goes there. So we shouldn't have 12 ohms across the 5 volts. So I'm wondering if this IC's gone or if it's one of the capacitors. There's another little capacitor just above it there. Let's try measuring resistance across that one. And again, 12 ohms. So I think we've got a short going on around here somewhere. Right, I'm going to clean this conformal coating off and then we'll be able to measure and remove components a bit easier. So I thought I'd get the thermal camera out and we'll see if we can see what's getting hot. So let's just get that over here. Well, that resistor, that looked discoloured's definitely getting hot. And we've got something there getting hot. Let's just see. Well, Looks like it could be the main IC. Yeah. So it looks like that IC might have failed. I could try injecting 5 volts into here just to double check. We'll see if the capacitors get hot or if it's the actual IC, but I've got a feeling it's the actual IC. The resistor's probably getting hot here because that's feeding the 5 volt regulator, which is then being shorted out by this IC here. So we'll connect this up to the bench power supply and we'll give it, I don't know, 1 volt at 1 amp or whatever, and then we'll see what gets hot. But I think it's that chip. Right, it's set up to the bench power supply. I'm just going to switch it on now. And it looks like that IC is getting hot. Just there. I mean, it's actually drawn that much current now for some reason. And it's actually getting that hot. Let's switch the bench power supply off again. Just switch this camera off. It looks like the short's pretty much gone now. I wonder if using the bench power supplies blown the short or something that was in this microcontroller perhaps. We don't have 12 ohms now. Let's see what the battery does. Let's go on the output here. I'm going to volts DC. Well, we've got 40 volts there, but then it does rapidly drop off when after you've held the button in for a little while. So I wonder if that IC is indeed faulty. One of the I/O pins or inputs or something shorted, and we've blown whatever was shorted away by connecting to the bench power supply. I don't think this is going to be fixable as such. We might be able to work around it by disconnecting the microcontroller, but then that runs the risk of the battery overheating. And I couldn't see a current sense resistor, so I don't know if it actually measures the current. What the microcontroller is probably for, it probably measures the battery temperature and also the battery voltage. So if they drop below a certain level, like if the battery gets too low, it would disconnect. I mean, it might have some kind of BMS in the battery itself. I know the Milwaukee batteries don't because that's handled in the tool. And we've got the temperature sense here. So I couldn't see any markings on this IC. I did have a look under the microscope after I cleaned it, but there's no markings on it at all, so the markings have been removed. But I'm pretty sure it's a microcontroller because we've got a line here, which is normally for programming, goes to this pin, and then there's another line here, goes to one of the other pins over here. So I'm pretty sure this is a programming port for programming the microcontroller. I might connect the motor back up and then we'll see what it does when we pull the trigger, see if the motor actually just runs for a second and then cuts out, or if it continues to run. Well, I've connected the motor back up. Let's just plug it into the battery. Let's see what happens when we press the button. So it does attempt to start, but then it shuts down again. So we know the motor's okay, we know the switch is okay. It looks like that IC. I mean, you could attempt to bypass it, but that means there's going to be no protection on the battery for it overheating, or low voltage protection possibly. But the numbers have actually been sanded off. I see, I had another quick look under the microscope and you can't see any numbers on this at all. They've just been sanded. And even if we could get a replacement microcontroller, we wouldn't have the code to program into it, because normally these are read protected, so you can't read the code out of them. So I'll see if I can work out if we can possibly bypass it. So what I've worked out, this pin here on the microcontroller seems to be the output that drives the MOSFET that controls the motor. So what I'm planning on doing is using this piece of wire here and bridging it to the 5 volts, which gets activated when you press the trigger. So pretty much we're sending 5 volts to the output pin here, which hopefully should then drive the MOSFET. So I'll put a bit of solder on here. Let's grab some tweezers. So something a bit like that, I think. Right, we'll see what that does. Got the Bodge wire on. Let's see what happens when we press the trigger then. Well, that seems to work. So I think we'll put it back together and we'll give it a test, but I think that's all we're going to be able to do with this. We're not going to be able to fix it properly because we can't get one of these microcontrollers. Right, I'll assemble it and then we'll see what happens. We'll see if we can cut some metal or something with it. Well, it's all back together. Let's just see if we can cut this bit of metal here. So it actually seems to work okay. Right then, have you ever done something like this where you've had to bypass a part of a circuit or something to make something work again? Let me know in the comments below. Right, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.